Hello. In this section, we specifically focus on dividing with polynomials. We saw a little preview of what that looked like in the following section. There's just going to be some kind of more advanced cases that we're looking at here. So I really like to connect what we're doing to what you've understood prior. So we're going to really time travel back with this warm-up for the section today. We're going to go back to elementary school and ask yourself, how did we do long division with numbers? Because it turns out you can actually do long division with expressions or polynomials in high school. So this is kind of the elementary version of what we're going to look at in this lesson in high school. So try to recall, try the best that you can in conducting the following long division questions. So pause the video now, see what you remember, unpause it once you've given it a try and want to see how we did this before. So without using a calculator, pencil and paper, try long division of the following two questions. Okay, let's go over and talk about how we did this. So for the very first one, so we're asking how many times does 9 go in the number 2016? First we asked how many times does 9 go into 2? Well, it doesn't, so technically it's 0. Then we move on to the next place value. How many times does 9 go into 20? Well, it goes into 20 twice. Technically 9 going into 2,200 times, but that's why we place it in the hundreds, but we're just looking at it as a 20. So 9 times 2 is 18, and then we subtract to see what's left over, how much I have left to divide 9 into. 20 minus 18 is 2, and then what do we do next? You bring the 1 down, and then you just repeat. You ask yourself, how many times does 9 go into 21? Well, again, it goes in twice. 9 times 2 is 18 again. 18 minus, or 18 taking away from 21 will be 3. And then bring down your 6. How many times does 9 go into 36? It goes in perfectly 4 times. 9 times 4 is 36 with a remainder of 0. So we'd say 224, either remainder 0 or 0.0, but it's 224. That's when it goes in evenly or perfectly. Next one, I think, has remainder, if I remember correctly. So again, we ask ourselves, well, this time there's 2. So which one's the guiding one, the bigger power? The 1 is really what's guiding me. It's the power of 10. So how many times does 12 go into 25? Or how many times does really 10 go into 25? Well, it goes in twice. So 2 times 12 would be 24. Subtract, I get 1, and then I bring down my remainder. How many times does 12 go into 11? It doesn't, so we would say 0. And then we need to bring down, again, the next one. How many times does 12 go into 118? So you could do, well, 12 times 10 is 120, so it's got to be less than that. It's got to be a 9. So 12 times 9 is going to end up being, what, 108? And when I subtract, I get 10 as my remainder. 12 doesn't go into 10, so you could either write 209 and 10 twelfths or remainder 10. Let's write it as 10 twelfths or remainder 10. It meant the same thing, but there you go. You could simplify 10 twelfths to be 5/6. It'd be the same thing, but that's how we did it when we had remainders. We would write it as the remainder divided by what I was dividing. So that's how we did it in elementary school. Hold on to that. We're going to need that in the second half of the lesson. We're going to start with some nicer cases first. So in this section, we're looking at taking a polynomial in first simple cases, dividing by a monomial, a single-termed polynomial. So 2x squared plus 16 dividing by 2x. Let's write it as 2x squared plus 16x divide by 2x. The first thing that you should do is you should look to factor everything that you can before going and simplifying. The top is going to be greatest common factor factoring. What's the biggest number I can divide out of 2 and 16? Well, I can divide out of 2. What's the most amount of x that I can divide out of x squared and x? Well, a single x. What is left behind? An x plus an 8. Down below, I have 2x. I'm going to put parentheses around all my factors. Now I see what can simplify. 2x and 2x will make 1. So my final answer is just going to be x plus 8. Second one, 9x to the fifth minus 5x squared minus 12, all dividing by 3x. Kind of write it similar to the way I did the first one. 9x to the fifth minus 5x squared minus 12, all dividing 3x. Again, factor everything that you can. Divide out the most that you can. The most that I can divide out of the top is just a 3. I can't divide any x's out, so this would be a 3. And then what's left behind? Well, a 3x to the 5th. Oh no, I can't even divide out a 3 because the 5's not divisible by 3. Ooh, we need to back this up and go looking at 9x to the 5th minus 5x squared minus 12, all dividing by 3x. I might have to do this single term by single term then. So 9x to the 5th minus 5x squared minus 12, all dividing by 3x. As you saw, the 5 won't divide out at 3, so I can't use the strategy that I did before. Instead, what I'm going to have to do is divide each term by 3x. So this will look like 9x to the 5th over 3x minus 5x squared over 3x minus 12 over 3x. 9 over 3 will make 3. X to the 5th over x to the 1st will make x to the 4th. 5 minus 3 will just be minus 5/3. That won't simplify. X squared over x to the 1st is x. 12 over 3 will make 4. And then I have it over x, so it'll be minus 4 over x. When you write it all out, it'll be 3x to the 4th minus 5/3 x minus 4 over x. Let's see if that strategy would have worked over here. Instead of doing greatest common factor factoring, what if I had just divided by both of the statements up top? 2x squared over 2x plus 16x over 2x. 2 over 2 makes 1, x squared over x makes x, 16 over 2 makes 8, x over x simplifies, and hey, I get the same thing. So that actually would have worked if I hadn't done greatest common factor factoring. So the takeaway is, if you have a monomial, you can divide each term in the first expression by the monomial, and you'll get the answer. So that's dividing by a monomial. How do we do dividing by a binomial? I cannot do that in this one. I'm going to have to factor everything that I can because x plus 3 is grouped together. It's one single statement. So I would write this as x squared minus 2x minus 15 over x plus 3. You cannot try to divide it into each statement. It's a longer expression. So I'm going to have to factor the top. What two numbers multiply to make negative 15 add up to be negative 2? It's going to be x minus 5, x plus 3. And the bottom also has x plus 3. That's nice. Those then will simplify out. So I'm left with x minus 5 as my final answer. So if I'm dividing by a binomial, I better be able to factor the top part and then cancel out the binomial term on bottom is most likely how it will go about. So monomial, divide each term. Binomial, just factor the top and you should find a common factor. I'm going to ask you to try a monomial and a binomial case. So pause the video now. Try the following. If it's a monomial, you can divide each term. A binomial, you better be able to factor the first part. So pause the video now for maybe a minute and a half, 2 minutes. Unpause it once you've had a chance to try. Okay, welcome back. First one, if you divide each of the terms by 5x, you're going to get 2x to the 5th minus 4x cubed minus 3. The second one, this will factor to be x plus 3 and x plus 8. It's getting divided by x plus 8. That'll cancel out, and you'll be left with x plus 3. So there you are. Just divide each of these terms by 5x. 10 over 5 is 2. X to the 6 over x is x to the 5th. Negative 20 divided by 5 is negative 4. X to the 4th over x will make x cubed. Last part, negative 15 being divided by 5 makes negative 3. X divided by x makes 1. That's where you get that statement. So there's a dividing by a monomial and a binomial. Last part is the special case. Let's say I have the following. Well, I've got a dividing it by a binomial, so I would try to factor the top. I need two numbers that multiply to make 12, add up to be 4. You can search high and low, but the problem is that one can't be factored. So if the polynomial cannot be factored, or if there are no common factors by which to divide out, kind of like we do with the monomial case, we must use long division. So we're going to use long division, going back to what we did in elementary school when it won't divide evenly. So here we go. I'm going to write it like we even did with long division. If you need to, pause the video now, go back and watch how we did it in elementary school with just numbers with the first warm-up question. I have x plus 3 dividing into x squared plus 4x plus 12. Now this is two statements, just like in the warm-up question, the number 12 is really 10 plus 2. The 10 is the guiding aspect, it's the bigger part of the expression. When we have polynomials, the biggest power, the degree of the polynomial is going to guide us. So the x is going to be the thing that guides us. The 3 just kind of comes along for the ride, just like the 2 came along for the ride in the number 12. So I'm going to ask myself, just like back here, I would ask how many times does the number 10 go into 25? I'm going to ask how many times does x go into x squared? Or another way of asking how many times does x go into x squared, essentially what I'm saying is, what do I need to multiply x by to get x squared? Well, I need to multiply by x. So that's the number that's going to go up top. Now, once I write this item up here, what do? I multiply this down below. X times x will make x squared. X times 3 is 3x. Now I need to subtract. X squared minus x squared is 0. That's how I know I did that right. I chose the x appropriately. And I also placed it in the x column to make sure I'm lining up my place values. 4x minus 3x is 1x. And then what do? I bring down the 12. So I get x plus 12. Now again, I ask, what do I need to multiply x by to get to x? How many times will x go into x? It'll go in there once. So I'm going to use just a different color, x plus 1. Then I multiply. 1 times x is x. 1 times 3 is 3. And then I subtract. X minus x makes 0. That's how you know you did this right. 12 minus 3 would make 9. That is my remainder. So there's two ways we would write this. When you first learned long division, you would put this whole remainder 9 bit, but then you learned about fractions. Instead of writing remainder 9, go back and look at how we did the warm-up one. When my remainder was 10 for my first part, what did I write? I wrote it as 10 twelfths, 10 dividing by the expression out front. So here, instead of writing remainder 9, I'm going to say I have the last part of, I'll use blue, and say it's 9x plus 3s. And that would be my final answer. X plus 1, and then plus 9x plus 3s, because 9 is my remainder. How do I know I did it right? Well, let's go back. How could I ever know that I did this right when I was doing 9 dividing into 2016? Well, I could check by multiplying 224 by 9, and I should get 2016. How do I check division? I multiply, and that's exactly what we're going to do here. How do I check and know if I did this right? We're going to verify our answer by multiplying. So I need to be able to verify that when I take this expression and divide it by x plus 3, I get this. So that means when I multiply x plus 3 by my answer, I should get x squared plus 4x plus 12. And this is how we're going to do it. We're going to do it by just distributing. There's really two statements going on here. There's this blue statement and this red statement. So when I distribute through x plus 3, we'll do essentially the green statement times the blue statement. And then when I distribute this again over to here, I'll have the green statement times the red statement. If you need to, pause the video now, make sure you understand how that's a valid move that we just did. It's just distributing, realizing this is really part of the expression, and that's another part of the expression, the thing that went in cleanly, and then my remainder part. Now I just multiply. This is just, double distribution, multiple distribution, x times x, x squared. Or x times 1, 1x. 3 times x, 3x. 3 times 1, 3. Over here, look at this though. X plus 3 is really x plus 3 over 1. This is a fraction times a fraction. These bits right here are going to cancel each other when they multiply. So I'm just left with 9 over 1. So this would be plus 9 when it all comes out of that. Now I just combine like terms. X squared plus 1x and 3x is 4x's. 3 and 9 add together and make 12, and voila, we did it correctly. We got the final answer. So as strange as it may seem, that I can actually write remainders with expressions. But this probably seemed as strange to you when you were first learning about remainders with numbers in elementary school. It's just been so long, and you've become so common with fractions that it doesn't seem as strange. And someday this won't seem as strange to you, I promise. But take a look over it, make sure you understand the steps that we did. Okay, we're going to do one more example of doing a long division, then I'll have you try one. So long division, even if we have a missing term. So x minus 1 dividing into 2x cubed plus 2x squared. There's a missing term here. There's not any x's, so I need to write a placeholder of 0 x's minus 4. Now I just go through again. X is my guide. How many times will x go into 2x cubed? Or a better way of asking that is, what do I need to multiply x by to get to 2x cubed? Well, I need a 2, and I need x squared in order to multiply 2x squared by x to get 2x cubed. Or that's how many times x will go into 2x cubed. Once I have this item, I multiply. Let's actually color code. So I'll use red so you can see each step. 2x squared times x, that makes 2x cubed. 2x squared times the minus 1 will make minus 2x squared. Now I'm going to subtract. These cancel out, which lets you know that you chose appropriately. 2 minus negative 2, that's minus a negative. That'll make a positive. That's a 4x squared. Bring down your next statement. Again, I ask, what do I need to multiply x by to get to 4x squared? Well, I need a 4, and I need an x. And I multiply. 4x times x is 4x squared. 4x times minus 1 is minus 4x. And again, I subtract. These cancel out, which lets me know I chose appropriately. 0 minus a negative 4 makes positive 4x. And again, bring down the last statement. 4x minus 4. What do I need to multiply x by to get to 4x? Well, I need a 4. I don't need any more x's because it already has 1, and I only need 1. So 4 times x makes 4x. 4 times negative 1 is minus 4. I subtract. 4x minus 4x is 0. Negative 4 minus a negative 4 is like negative 4 plus 4. And hey, I get a remainder of 0. This goes in perfectly. 2x squared plus 4x plus 4 is my answer. How could I check? I could check by taking my answer of 2x squared plus 4x plus 4 and multiplying it by x minus 1. Have to do some double distribution 3 times here. And I would get my original statement of 2x cubed. I think it was plus 2x squared. Is that right? 2x cubed plus 2x squared minus 4. If you want to, check it for yourself. You would do distribution, double distribution 3 times, and you'll end up getting that statement. So there you go. That's how we can use long division when I can't factor the first statement. I'm going to give you a chance to try. This actually is number 30 from the book. So you're kind of knocking out a practice homework question anyway. So try doing division with this one. I'll let you know it has a remainder. So pause the video now, unpause it once you've given it a try and you want to see what the answer is. Okay, welcome back. I think the book uses b's instead of x's. Doesn't matter what you call the variable. The process is still the same. It looks like this. What do I need to multiply b by to get b squared? I need a b. And then I will end up getting b squared plus 5b. Subtract. I'm left with negative 2b's. What do I need to multiply b by to get to negative 2b? I need a negative 2. I go multiplying through. I get negative 2b minus 10. Subtract. I'm left with a remainder of 1. That remainder then can be written as 1 over my divisor of b plus 5. And there you go. That is number 30 from the book, or just an extra example. So that's it for today. Thank you very much. Have a good day.